All right, so we're back talking about section 1.7. 1.7 is all about inequalities. Inequalities means you have a less than or greater than symbol in your problem. And we've seen the three types of cases we're studying in 1.7. We've seen linear equations, quadratic equation, and we've also seen fractions. We know how to solve those as equations and find the solution. But in this section, we take it a step further and we do it with an inequality, and we shade in an entire region that's a solution. Instead of just one answer, we have a whole section on the number line. That's our answer. All right, so this last part of 1.7, we're looking at the fraction inequalities. Remember the word rational has the word ratio in it. Ratio means you're comparing a top and a bottom, so a fraction, a numerator compared to a denominator. So rational in math always means fraction. So we got to do the fractions here. Okay, so if you're reading along with me on your note packet, let's make sure I don't miss anything here with you. It says rational inequalities involve fractions. We must always be aware that any value that makes the denominator equal 0 can't be in the solution set. So if we're doing an algebraic fraction like 1 over x, if that's our problem, we've got to be mindful x cannot equal 0. We cannot have a 0 in the denominator. So this will actually create a situation known as an asymptote when graphed. Any place that you have an undefined part of the graph, and we're doing just the x-axis graphing in chapter 1. We're only doing x-axis graphing for the horizontal graph. So where it is undefined, the graph is going to be confused, I say. It can't cross that value because it's not defined in math, so you cannot include that. So that's a critical part of our graph, and we will note anything that makes the denominator of these fractions equal 0, we'll have to leave a spot on our graph to denote that. It also creates a split in the graph at any x value that makes it equal to 0. So there is a boundary line at any value that makes the denominator equal 0, as well as the solution. Just like all of our other examples, when we did linears, we would solve it, and then that made a boundary. When we did quadratics, we would solve the quadratics. There was two solutions; those made boundaries. Same thing here. We solve the equation that makes one of our boundaries, and then the other boundary may come from any part that makes it undefined. So that's the two things we're looking for here. What is the solution to the equation? Plus 2, is there any place it's undefined? We'll make our boundary lines and proceed just like we have been in the last video. We'll cut the number line at those boundaries, and then we'll check in each region to see which part works back in the original problem, taking a test point. All right, so here we go. Oh, and there's a big note on this next to the last page, big note. So do note this. It says you can't include any value that makes the denominator equal 0. So that whole talk about whether to use parentheses or brackets that I've had in the last two examples, we use parentheses if there's no line under it. We use a bracket if there is a line under it. We learned that earlier. But the exception to the rule is even if there's a line under the inequality, we cannot include or bracket a value that makes it undefined. And we'll see that in one of our examples here. So we'll be referring to that again. All right, so our example in your packet to get us started, x minus 3 over x plus 4 greater than 0. So if you have just one fraction already isolated and 0 on this side, that's sort of be standard form for our rational functions or rational inequalities. One thing, like I said, the denominator, you'll say, what would make that equal 0? Because you cannot have that value. That'll make a break in the graph. So at -4, does everybody see if you type in -4 for x plus 4, you get a big 0 in the denominator, and that's where the graph is undefined. So it's a critical point. So let's go ahead and just note that at -4, there's definitely a boundary or a break in the graph we have to note. So that's one thing. Then the second thing is, what is the solution? This is where it's undefined, and then we also need the solution, like we have on all the other methods. Well, the solution is, since this is we could think of it as a proportion, and write it x minus 3 over x plus 4 equals, to solve it, equals 0 over 1. So it's kind of like a proportion there, a fraction equal to a fraction we could think of it as. And you can do the cross products. X minus 3 times 1 is x minus 3. And then the denominator will be times 0, so it equals 0. And then to solve that, x is 3. So the shortcut is, you might notice, every time we do this, to find the solution, if we've got a fraction and a 0 here, when you cross multiply, the 0 times the denominator zeroes that out, and then this is times the understood 1 under that. So you just have the numerator set equal to 0. So it really is just as simple as set the numerator equal to 0, that's the solution. Set the denominator equal to 0, that's where it's undefined, and that's the 2 breaks in the graph. So at -4 and 3. And then we check each region to see which parts are solutions to the original. 0 is always an easiest number to check. So if I do 0 back in the original problem, I'd have 0 minus 3 over 0 plus 4. And then that question is, does that work? Does my test point work? That would be -3/4 when you drop all the zeros. 0 minus 3 and 0 plus 4. And that's not true. -3/4 is not greater than 0, so that did not work. So I'm suspecting the wings here. So you take a test point, like maybe 4. Do it again. Check your region. 4 for our test point. And say, well, is that true? 4 minus 3 is 1. 4 plus 4 is 8. Is that true? Sure, 1/8 is greater than 0. So that worked, so that gets shaded. And then we can check over here, say check -5, see if it works. Again, it does. Let's say we did, it works. And we shade. Now, on this one, I won't have to worry about parentheses and brackets and that exception to the rule kind of thing that I mentioned because there's no line under it. I'm going to use parentheses anyway. But say it did have a line under it, which normally means include, and use a bracket, we would not be able to include -4 regardless. Even if there's a line, -4 is a big no-no. -4 is where it's undefined, not defined in math, so it would be parentheses. But if it had a line under it, we would bracket the one that's the solution, what solves it, what makes it equal 0. So we'll write this as this interval is -∞ to -4, union this interval 3 to +∞. The 2 sections, and then sort of like a plus sign in math. All right, so I'd like you to try on the next page. You have one similar to that. So here's the one on the next page, a practice problem for you. Please pause the video and try that solo before I reveal it. So this one is very similar. It's already got one fraction consolidated and 0. So you're ready to set the numerator equal to 0 and the denominator equal to 0. Solving each part gives us our 2 boundaries for different reasons. This one's the boundary, let's see, -5 is what would solve it, make it equal 0. And this one's the boundary because it's where it's undefined. So, but they're both boundaries or breaks in the graph. If we graph this, which if you wanted to do y equals this, you would see the graph is broken. There's something happening, critical thing happening at -5 and 2. And we're just asking which part of the graph, if we were to graph it, is greater than 0, or the part above the graph. We do that in this chapter by just taking a test point. So I usually try to find my 0, plug it in for x, and say, is that true? And we can check that out. It is not true. So don't shade that section. Check something over here, say like 3. Is 3 plus 5? That's 8. Over 3 minus 2, 1. Is that greater than 0? It is. So I shade that. And then, to be thorough, we check this one too with a test point such as -6 or anything back in this area. No line under it, so all parentheses for that. So we got -∞ up to -5, parentheses, union, and then 2 to infinity. All right. Now, the next series we want to go through, really the last thing, turning back the page, is an example where it's not just one consolidated fraction, and we have to get it in standard form before we can use this method. So a little bit harder example, this next example. Let me do one with you, and then I'll ask you to try one. So you'll notice this is a little tougher because it's not equal to 0. We can't just set the numerator equal to 0 and denominator equal to 0 because it wouldn't solve out. I suppose we could put that over 1 and cross multiply and do it that way. But if you view the example, or if you do it per the book's method, it recommends you bring the 3 across the line and consolidate it into one fraction. So bring 3 over, make it 3 over 1. And then add those two fractions together so it looks like the ones we just did, one consolidated fraction. Well, before we can add fractions, you can't do that without like denominators. Back to like old style, 1/2 plus 1/3. We can't combine that unless you get a like denominator of 6. So we're held to that standard for algebra too. Algebra is just general arithmetic. So we have to have a like denominator before we can combine those. Well, right here is the only denominator in use anyway, so we'll make that our common denominator. So this one stays as is. Here we would say, what do we do to make it this? Well, we times it by an x plus 4, so we times the top also by x plus 4. And really, you can see those would cancel right back out. We just added something to the top and bottom to make these like denominators. That could be canceled and it go back to right where it was. So that's legal to do that. You can add anything to top and bottom or add anything to left and right of an equation. Keeps balance. Well, that allows us then to combine this into one fraction, to combine the two fractions. So this negative will distribute. It'll be negative 3x. And negative 3 times 4, negative 12, all over the common denominator, x plus 4. X minus 3x is negative 2x. Negative 3 and negative 12 is negative 15. And now we're back to where we would have been starting on the last problem. Once you get a consolidated fraction and a 0, the step is numerator equal to 0, denominator set equal to 0. That gives you your two boundary lines. So let's do that. Negative 2x minus 15 equal to 0. And the denominator, which is where it will be undefined, at negative 4. That's the easier part. Over here, let's solve this. And it gives us negative 15 over 2. So we've got, that's what would solve it, basically the solution to the equation. That's where it's undefined. So even though there's a line under it here, I will use a bracket on the solution part, but I'll have to use a parenthesis. So I'm showing that I understand that you cannot include in the solution set something that would make it undefined. So we've got negative 15 over 2 and negative 4. Make sure you get those in the right order. This one's a little bit smaller to the left. Here's my first example where 0 isn't between my numbers. 0 is actually all the way over here since both of those are negative. So you know I like to check my 0 value. Back in the original problem is 0 minus 3 over 0 plus 4 greater than or equal to 3. That's the original problem, right? And that is not true. Negative 3/4 is not greater than or equal to 3. So we'll not be shading where the 0 test point was. Then I could check maybe negative 5 is between these 2 points. Is negative 5 minus 3 over negative 5 plus 4, is that true? That'd be negative 8 over negative 1, which would be positive 8, and that is greater than or equal to 3. That does check out. And so everything in that region should also work. And then I could check there. Let's say we didn't, it does not work. So back to that line under it. With the line under it, we should use a bracket around what solved it, made it equal 0, with the numerator equal to 0, but negative 4 is where it's undefined. That should be a parenthesis for sure. So the answer is between negative 15/2 with a bracket, comma, to negative 4 with a parenthesis. All right, so little details there. You really practice this in your homework, view the example until you get really good at that. and going through the process. All the things really on chapter 1 are like that. They're stepwise things that you can just kind of practice and practice until you've got it down pat. And that's what I recommend, that you just keep doing. If you have questions on it though, I hope you will reach out to me and let me know how I can help. All right, best wishes.